Hannes, you look so serious. Okay, now you're smiling. That's better.
Yeah. You know,
Keep up the good attitude. I know that's horrible.
Yeah.
Thank you for joining us.
Awesome.
Thank you guys for attending the meeting. I see good.
Welcome, everyone. Welcome, everyone. Good morning. This is the first session of the OAUTH work group, and let's get going. I think we're time here. Okay, it's taking some time. So, this applies here. So, and as you know, is used to control everything that we do at the IETF. So, if you're not familiar with that, please make sure you're get familiar with this as soon as possible. A few meeting tips. Please make sure to use the Meeteco application. We don't have blue sheets anymore, so that's the way we track how many people are attending. And this is your way of joining the queue.
Sorry, do you have the actual QR code somewhere?
Typically, it's there before. I think it's outside, but let me see. Hold on. Let me stop sharing if people don't have it.
Thank you.
Okay, I'll give you a minute here. People good? Okay. I didn't see any phones up in the air, so let's get going, I guess. Again, please use the Meeteco application to join the queue, and for a blue sheet, keep audio and video off, and please wear masks all the time. For remote participant, please make sure your audio and video are off unless you want to speak, and please use a headset. So we have two official sessions. This one and the next one is Friday, same time. We had two side meeting sessions planned. I don't know if Roman is here. I didn't see him, but there was some concern about. Here's Roman. So there was some concern about those side meetings from the ISG, and I let Roman talk a little bit about this.
Good morning, everyone. So I just walked into something with Roman come to the mic. So like 15 seconds, what am I at the mic to answer for? Side meetings. Yes. So the brass tacks is it is inappropriate to hold effectively working group meetings during the side meeting time. I mean, there's a hard line between what you use side meetings for and what the official meeting time is for. I fully kind of recognize that we're all here and we want to make maximum productivity for here to kind of make progress on everything and anything. And let's schedule as much time as we can, but the perspective from the ISG is there is meeting time and then there is side meetings, and we don't do official, we don't convene official meetings in the side meeting kind of slot. And I, again, appreciate that might not be a kind of a distinction. That's a distinction that does not maximize the time kind of we have here kind of together, but that is the IETF approach, sadly.
Thank you, Roman. Appreciate it.
I apologize for that because I know this came last minute. We were thinking of, I'm sure doing lots of productive things, and getting that pulled off probably is going to slow some things down. And the official IETF response is schedule more interims to include if you want to have in-person interim meetings.
Okay. Thank you, Roman. Roman and I have been also talking about this and try to find other ways, but we'll see. That's still ongoing discussion. Okay, thanks, Roman. Okay, quick updates on our documents. RAR and chart response for auth token inspection are in the RFC editor queue. The latter one has a misref there. I think it's waiting for the security BCP. So we'll talk about the security BCP in a sec. We have two documents that are in public. We requested publication for those two documents, and they have been with the IEG for some time, and now it is on the ISG telechat in April. That's good. I think we're progressing well there. And I think security BCP, Daniel, I think we were waiting for you to do some more update. Like, can you tell us what's the latest there? I think Hannes will, after that, take it and start talking about that right up there.
Yes. So we do have a couple of things there, editorial. I think some of which you identified, some which were identified previously. So we need to work on those. Together with Aaron, we checked whether OAuth 2.1 and the security BCP are actually aligned. And we identified some things that were discussed in 2.1, but not in the security BCP or vice versa. All things that are not new to the working group, so nothing surprising there, but things that we need to, where we need to align the two drafts.
Yeah.
And we're working on that. And then we have the course text provided by Mike that we discussed on the mailing list, and we need to integrate that.
Okay.
So these are the three things.
Okay. Well, when do you think we're done with those? Like, the reason is that we want to push this
Yes,
forward.
obviously. Yes, of course, we want to do that soon. So I hope to spend essentially the time after this meeting to get this
Okay.
going.
Okay. A few weeks after the IETF?
Yeah.
Okay.
2-3
Awesome.
weeks.
Awesome. Thank you, Daniel. Okay. Any questions, comments about this here? Okay.
Thanks for the work, Daniel.
Okay. Today's agenda. Christina and Daniel will start with the SDJOT. Aaron will talk about browser-based app and OAuth 2.1. Christina and Torsten will talk about client trust management. Nat will talk about POP security architecture, and Evan will talk about OAuth and SPIFFE. So it's an interesting topic here. So this is for today. For Friday, I'll be talking about JOT embedded tokens. Unfortunately, Dick didn't make it to Yokohama. Peter will be talking about cross-device flow. Peter and I will talk about identity chaining. And Peter will be talking about native apps UX. Aaron and Mike will be talking about two related documents, the authorization server discovery and protected resource metadata. So they're kind of together somehow. And then we end with Olav talking about power of attorney grant type. It's a draft that he put together there. So that's our agenda. Any comments, questions? Okay. Christina and Danielle. Do you want me to drive from here, or do you want to?
Should I just like stand like this?
You can.
So we-
Yeah.
Should I stand like this?
Yeah. We should sell these T-shirts.
Okay. Okay.
So these T-shirts were kindly sponsored by Torsten's
Thank
new
you.
company. Thank you. Okay, let's go. SD Jot. So thank you everybody for coming here. And thank you for giving us the first slot,
Sure.
the honor of the first talk today. We will be talking about SD Jot. If you haven't heard of SD Jot, you definitely should scan that QR code and read the draft. Obviously, I'm Daniel, in the transition from yes.com to auth lead duties. Christina, and we have Brian, who's, I think he's not online, and he can't be here today, but of course he's worked on this draft with us as well. Next slide, please. So, as the t-shirt says, simple is a feature. That's the motto for SD Jot. And next slide, please. We tried to come up with a very simple standard that's simple to use, simple to implement, that provides selective disclosure. So essentially the shortest path from A to B using standard cryptography. So it's a hash-based approach, sorted hash-based approach, uses standard formats, JORDs and JSON, and hopefully has a number of advantages that I won't go into detail here. Next slide, please. Just to get everybody on the same page, I'd like to quickly revisit what the current version of SD Jot looks like. We did a couple of changes after the last IETF meeting. We got a lot of good input there. And this is what the current version looks like, and hopefully the final version as well. So it takes some user data, like this JSON here. You can apply this to any JSON essentially. And then next slide, please. You decide which of these claims in there you want to make selectively disclosable. For all of those, you create a so-called disclosure. That's the thing that you see here on the right in green. Each disclosure is a JSON array consisting of 3 elements, a salt value, so just a cryptographic random nonce, the claim name, and the claim value. Very simple. And then, next slide, please. You hash those individually and put the hashes where the original claims used to be. Instead of just putting the claim name and value there, there's a new key that's called _SD, and in that key there's an array, and in that array must be at the same level as the original key. You put all the hashes of the disclosures. So here you can see this on the level of credential subject and an address. And then, as the next step, next slide please, you take the original thing where you replace the claim values with the hashes and sign over this. So standard Jot signing. And then, next slide please, you transform the disclosures into base64 encoding, and you use the tilde separator to put all of this together. So this makes one big thing with the SD Jot on the left side and the disclosures on the right side. Next slide, please. Now, what do you do with that? Well, the usual approach is that the issuer does the steps that I just talked about, so creates the SD Jot and the disclosures, and during the issuance process transfers all of this stuff to the end user or holder of the credential. So the credential then consisting of the SD Jot and the disclosures. Next slide, please. The holder or end user can then decide to go to some verifier and present the credential. And the verifier obviously then sends the thing that was signed by the issuer, the SD Jot, plus a selection of the disclosures. So it doesn't send all the disclosures usually, but only those disclosures for the claims that are to be released to that specific verifier. Next slide, please. If desired, the verifier can also add a so-called holder binding Jot, which means that essentially the holder creates a new job that is signed by the holder using a public key that is contained in the original SD job. So where the verifier says, I know that this is a key of this specific holder. So the issuer says that. So the verifier can see that the holder is actually in possession of the private key belonging to that public key that's in the SD job. Next slide, please. For the verification on the verifier side, the verifier checks the signature of the SD job, that it is actually from the issuer. The verifier then must hash over the disclosed disclosures and try to figure out where those hashes appear in the original SD job. That's a neat feature because the verifier actually has to calculate that hash before being able to tell what the original credential looks like. That means that any generic implementation of a verification actually implements the hash check, so you cannot skip checking that the disclosures were, whether the disclosures were modified or not. Then you take whatever has been disclosed to you and put it back into the original location in the SD job. You check the holder binding if that is required by your application, and you're done. That's the verification. Next slide, please. As I said, we had these format changes after the last IETF meeting. We had another update since then. The most important points that we updated is that we now have, or that we now allow what we call nested disclosures. So within a disclosure, there can be an object which again contains the hashes of other disclosures. That's a feature that's actually quite natural to the design that we have. We, for whatever reason, disallowed that in the previous version, but then we noticed that it's not only easier to actually allow it, but also it enables you to create SD jobs with a very fine granularity. So, for example, if you have an address claim, you can do selective disclosure on all the elements in the address claim and the address claim itself. Yeah, so it doesn't add much in terms of implementation complexity, but it allows for more flexibility when creating the SD jobs. We also added an example for a W3C VC data model type credential that features JSON LD. So we also show that you can actually use JSON LD with SD job. And we improved various other parts of the spec, so many editorial things, but also the security and privacy considerations, discussions on the various features like holder binding, and so on. Yeah, so many improvements since the last version, and hopefully the spec is in a much better shape now than it was before. And from here on, I think Christina will take over.
On the previous slide, the second bullet point, when there was JSON OD, the point was the editor's realization was that the SD job can be used to sign any JSON. So once that was clear, it could be JSON OD was kind of just the logic, so just to add the color. I'll cover 3 discussion points. Yes, sorry, next slide. I'll cover 3 discussion points we wanted to bring with the working group. We were hoping to continue some of them in the side meetings, which we don't have now. So if you have opinions, either please speak now or catch us in the hallway. The first one is being media types. Then do we want to allow self-disclosure of individual elements within the array? And do we need and how do we do SD job where JWS is not complex serialization, but JSON serialization? So I'll go one by one. Next slide, please. Thank you. So for media types, there are, I think, 2-3 separate conversations that should be separate. So the first bullet point, it's a high level. SDJOT is not JWS. As you have seen in the beginning, the processing rules are different. So yes, you can reuse majority of the existing libraries, but still, like, it would be good to have an identifier to signal that it is an SDJOT. And so second bullet point where it could be used is where I think it should be differentiated. So there is an issue where someone was asking, how about HTTP request response? So, application / JOT kind of use case. I just want to signal that I am sending the payload would be an SDJOT of HTTPS message. The second point is the type header of an SDJOT. So I think JOT best practice document recommends to clearly type the signed object. So how do you tell it's in SDJOT? And they're potentially immediate type for the payload. So as I said, the payload could be any JSON. So potentially we do need immediate type for that payload too, but that's, I think, a bit separate, probably layer. And then also if a JWE, which obviously you could use JWE to encrypt SDJOT, so CTY in the header of JWE. And we had three proposals. How about SD-JOT-issuance and SD-JOT-presentation for HTTP request response? And this -issuance-presentation is pretty important because whether you're sending all disclosures or only part of disclosures that you're actually disclosing is a big difference. And also whether the holder binding mechanism is present or not would be the big difference. For the header of an actual SDJOT in the HOSA header, maybe just simple SD-JOT media type would be sufficient. And the third, for the general purpose, reserving plus SD-JOT media type structured suffix seemed like a good idea. So do we want all? Is one more important than the other? I think that, like we have opinions, but we would like some working group opinions as well. So there are certain issues, and actually a PR where I tried to clarify how it might look like. So please take a look at those. Next slide.
So do you want to take feedback on those if somebody has any? Or
Sure, yeah.
Anybody has any thoughts on those? No.
That's less controversial.
Okay.
Okay.
Mike has.
Ori.
Yeah,
I
Ori,
think Ori is.
go ahead.
Ori Steele. I'm in favor of the specific typing. I'm in favor of reserving the SD JWT structured suffix because we want to be able to distinguish SD JOT structured suffix from regular JOT structured suffix. The IANA registry already contains a lot of plus JWT structured suffix examples, and it'll become immediately confusing if there isn't a way to distinguish there. So I'm in favor of the structured suffix.
Thank you.
So Mike Jones, there is a, as you know, plus JOT structured suffix. It would be logical to use the media type application / SD plus JOT for SD JOTs because they're a JOT and they're more specific than that.
I disagree, but do you want to react now?
It's up to you. Like, do you want to continue this discussion now? Do you want to continue? What is it? No, you still have time.
Okay.
It depends on. Oh, you still have lots of slides there. So let's keep going then.
I think there's. Oh. You're good.
Ori.
And I think Mike Park had a. Oh.
Okay.
Just to clarify what you were saying, Mike, are you saying you want a structured suffix of SD plus JWT as opposed to SD dash JWT?
Yeah.
Okay, Michael?
Mike Perrock. Just especially after having sat through Media Man yesterday, while I do appreciate, actually in a sense, quite a lot, the SD plus JWT notion from a structured suffix, I think it could be potentially problematic. So I would definitely talk to the folks at the Media Man side, because there's a lot of work to be done on the structured suffix side before that kind of multi-plus type scenario becomes really valid, I think.
Thank you. Yeah,
We discussed that inside.
I have opinions, but yes, let's discuss it later. Yeah, next slide, please.
Okay. You seem to have lots of slides, so I don't know if we have the time to cover all of
No,
them.
it should be 3 or 4 more. Yeah, I
No,
think.
there are about 6, 7 more,
Uh-oh.
probably.
Okay, so second
Yeah.
topic, set disclosure for individual array elements. So one example is, let's say someone in Europe has passports from multiple countries. So you have passport, country, and then array, European Union, citizen card, let's say Germany, France. So what if I want to disclose only one of those? Was the use case presented? So we think from a feature perspective, it's feasible, and I think next slide would have concrete proposal how to do it. But do we need it? So here the input we were requesting mainly is, do you have a use case, or have you seen the need in the market to do this approach? Do you have a need to disclose only 1 or 2 out of all the array elements? And so 2 approaches you see on the screen are the proposal side maybe Daniel has been working on. So first would be so one thing is receiver of an SD-JOT would have to differentiate whether array contains hashes or plain text. And to do that, one proposal is to put underscore SD element to signal, like as a first element in array, to signal that, hey, what follows are hashes, not plain text values. And it's usual 2 options, right? The second options would be let's namespace so that each hash would have underscore SD colon and or anything similar in front of them to clearly namespace indicate it's a hash. Because yeah, potentially we wanted to yeah. Okay, I'll stop here because I see the queue.
Torsten? Sorry. Sorry, like, did you join the mic? Go ahead, Torsten. Go ahead, Torsten.
Torsten Lodderstedt. Is it a bad sign that my name now is called in red? The background?
It's unlocked. It's unlocked.
Okay. Ah, okay. Okay. No, I'm feeling better. Thank you.
So the
Thank you.
bad side.
You're good?
All right, just to give him feedback on that feature, so, and to add some color to the feature, I have been experimenting with educational credentials and SD-JOTs a lot, and what you see there is a lot of arrays that contain achievements, and if you want to just selectively disclose the achievements, then you definitely want to have that selective disclosure feature on the individual entries of the array. So I'm absolutely appreciating that you're working on that feature. Thank you.
Okay. Sorry, did you join the queue?
Oh, I don't know how to join the queue.
Okay, that's fine. Go ahead. Go ahead to the mic. Go ahead to the mic. Go.
Okay. Is that it?
Yeah.
Okay. Thank you. So I just have a quick
State
question.
your name first, please.
So, okay. I'm Guilin Wang from Huawei International. So I'm a newcomer for this work item. So my question is that it's very interesting. So I would like to know technically which kind of the crypto scheme you used here, maybe from some academic paper or something, which particular paper or something?
Sure. It's a very simple approach. So you just the idea is you just hash the plaintext value and you sign over the hash of the plaintext value. To avoid that, you can just from looking at the hash and then guessing the plaintext value, that would be problematic. So what we do is you add a cryptographic nonce before hashing,
Okay.
meaning that you cannot guess the plaintext values.
Okay, I got it. So
so
basically,
it's,
you designed the scheme.
It's not our invention, so it's called a sorted hash-based approach.
Okay.
It was used, for example, by MDoc, but it's also not a new thing. So there have been other approaches as well.
Okay, thank you. Because in crypto schemes, there are something like group signature, ring signature, etc. It's much more complex. But I know.
Yeah, so I think from an
idea.
algorithm perspective, you need a hashing algorithm. So like
Mhm.
SHA-256 is the basic one that we have in the spec. And on top of that, when you're signing a JWS, you can use whatever JWS signatures you support. So from an algorithm choice perspective, like that's what you need.
Okay.
Thank you. Hey, Tobias.
Yeah, just going back to that proposal, just so understand, for the array elements, what data types from a JSON perspective would you be looking to support for the claim values? Is that objects or just like literal values, like basic types like strings, numbers, booleans?
Anything.
Anything.
Yes.
So how would you handle a case where you have an array of objects?
Well, it would look just like this. But the disclosure, the array that was created, would contain in the position of the last element an object.
Right. Okay. I'll
it's the
ask
same
after.
as we have currently.
Yeah.
Where essentially the hash takes the place of whatever
Right.
the thing was before,
Yeah.
which can be an object, integer, whatever.
And so the only other like feedback I had on this was that in approach 2, you do, unless you consistently validate all the elements in the array to have the prefix, then you might end up with a mixed. You'd get an ambiguity of, am I looking at this as a map or as an object, basically in terms of what nationalities are supposed to represent.
Yeah.
So I would say like a single directive that gives you a single point of evaluation there, like in approach 1, makes more sense. But it does raise the question of whether or not you should have an object structure maybe with an embedded array instead of like relying upon the first element in the array. Just an alternative approach.
So there are certainly pros and cons for each approach. These two are very close to the original structure, although the first one changes the number of elements in the array. So yeah, an object is certainly another option.
Okay, we need to wrap up this.
Yes. So last topic was, next slide, please. Thank you. So as most of you know, GWS RFC allows for 2 types of serialization: complex serialization and JSON serialization. And in Europe, there are things called JDIS signatures that use JSON serialization, and there are implementers from Europe asking, how do we do SDJOT with JSON serialization? It wouldn't be a breaking change. It would be an additional way how to sign it. Again, there's a GitHub issue number, and next slide would have one proposal. So that's where we disagree, but this is Daniel's proposal on the slide, where so essentially JSON serialization would have a JSON object where payload and the signature are separate key value pairs, and introducing additional key value pair disclosures array, which would have those disclosures instead of doing SDJOT to that disclosure to that disclosure. You would put disclosures into this array. And another approach would be where SDJOT before the to the disclosure would be a JSON serialized JWS, but basically for Euro encoded. So pros and cons would be, like, the approach you see on the screen is probably cleaner because there's one less base or one less encoding step. The second approach would be, but the approach you see on the screen would mean, depending whether it's complex serialization or JSON serialization, potentially how you treat combined format of presentation, that the term we use for a set of SDJOT plus disclosures, how you process that would be different based on the serialization type. The second approach is, again, one extra encoding step, but you can use the same processing rules for this combined format, regardless whether it's JSON serialized or complex serialized. What slide do we have next?
You want to take some, anybody has any thoughts on this?
Like if there's
feedback?
Input, that would be helpful.
Maybe a quick one, because you need, yeah.
Okay, so next slide we can skip.
Okay. No, you have 3 more.
No, you can go to the last slide.
Oh, go
Yeah,
to the last.
please go ahead and go
Oh,
to the
okay.
last slide.
This one.
Yeah, so the specification contains concrete examples, which were generated by the Python reference implementation written in Python by our genius Daniel Fett. Heads up that we now have all issues and PRs in the same GitHub repository, but in the future we might be separating that Python reference implementation into a separate GitHub just for clarity, just in case you see that. And then we have 1, 2, 3, 4, 5, 6 from Python code separately open source implementations. There are 2 new ones. One in TypeScript by Ori, thank you Ori, which is, oh, here, sorry, that is mainly focuses on verifiable credentials kind of use case, which is great if you're interested in that. And then we have SDJ new implementation in Java from Ostlades that tackles it, and README in that repo is like an absolutely great summary of a specification. So you might want to actually start there, for example. Yeah, so.
Awesome. Any last comments, thoughts? Thank you, Christina and Daniel.
Thank you.
Thank you. Aaron.
Can you
Yes.
make my thing work?
Yeah.
All right. Hello. I'm Aaron Parecki. Since Brian's not here, I thought I would include some photos of the area that I took this last week. It's not Yokohama. This is in Tokyo, but close enough. So I'm going to start with an update on OAuth for browser-based apps. The summary of this draft is this is a best practices document that talks about using OAuth for applications running in a browser, typically written in JavaScript, but any browser executing language would qualify. And that includes apps that may or may not have a backend component as part of the JavaScript or browser-based code. Kind of like this is supposed to be the complementary version of the native apps best current practice that was written several years ago that talks about specifics for native app environments. So there's been 2 revisions since the last time we have met, and a bunch of good changes since then based on the discussions we had at the last meeting. The biggest change in the draft is this top bullet point. There's a new section, whole new section in the draft that talks about the different options available for storing tokens in a browser after they have been acquired. And that covers everything from using local storage that is, JavaScript, writing into that and reading data from it. Also keeping the tokens away from the browser by using a backend component. So it covers that whole range of options. Also in that section is a part that talks about why not to use the JavaScript cookie API to store tokens, which hopefully nobody is doing. There is a new section that talks about sender constrained tokens and adding a reference to Depop as a way to do that, since that is kind of one of the goals of Depop is to be a browser accessible version of sender constrained tokens. There's in the draft, there's the sort of the main part of the draft is this architecture patterns to talk about the different pure JavaScript apps versus apps with a backend, and then within that, whether the backend is entirely a proxy or for the JavaScript or just a proxy to acquire the tokens. That whole section, I've now rephrased it to focus on the goal of acquiring tokens rather than like building the app. So it's really what we're talking about in the OAuth world is how does the app get the tokens? Some corrections of terminology. There's some rearranging of bits of the doc, which is all just sort of good changes, but not super interesting, I think. There's a note about the implicit flow, which now also mentions the fact that one of the main points of it was that CORS wasn't really possible, or in browsers when OAuth was written. And there was a lot of discussion about the service worker pattern on the list and off the list. And I think we've resolved that discussion mainly by essentially describing better the limitations available, or that are part of using service workers as a way to manage an OAuth flow. So that's what's new. A lot of that, again, this is mostly based on the discussions we've already had, so hopefully this is not surprising to anybody. Two sort of main issues that I want to wrap up before this is ready to go. Somebody brought up a new variation of using a backend, which is to use the backend to quote store the tokens, but storing them as HTTP only cookies. So it's not JavaScript accessible cookies. There's no storage, there's no persistent storage in the backend itself, but it's using cookies to be where the tokens live. That is not in the draft yet. I think it's a valid pattern to add. And again, there are interesting differences compared to the other patterns, which I think makes it interesting to call out. So I do plan on adding a section that talks about that. If anybody has opinions about that, please make them known. Again, the goal of this draft is not to say any one of these is the one way you should write your apps. It's to point out all the differences in and trade-offs in all the different options available. And the last topic here is this idea of storage isolation, which kind of gets to the core of this section, the new section that was added in the last couple of versions about storing tokens in browsers. The short version is there is no best solution for storing tokens in browsers because of limitations of browsers. Any API that is accessible to the browsing context is vulnerable to cross-site scripting attacks, and the only way to avoid the risk of storing tokens being vulnerable to cross-site scripting attacks is to not put them in browsing context accessible code. In other words, use a backend and keep the tokens there, which kind of really just moves the problem around, doesn't entirely solve the problem. A service worker is a decent option because the storage, the service worker memory is not accessible to the browsing context. However, there isn't a persistent API isolated to service workers. There's only the index DB, which is also it's like shared with the rest of the app. So there isn't really a best option. So one of the things that came up in this discussion was, should we, as a working group, document this as like there is a gap in the browser technology that we would like to use. If it existed, we would have a better solution to this, and like formally document that as like this is a request to the rest of the community involved in making browsers and operating systems for creating an API that is more suited to storing tokens in browsers, I guess.
Torsten.
Hey, this is Torsten speaking. So first of all, I think you already have your best practice in mind. I think the text you just said before you started to talk about service workers is the text that should be in the best current practice, right? Just use the backend for that. And I'm not sure whether a call for action is something that you should put in a BCP. I think we as a working group could reach out to the respective community and talk to them. I wouldn't put that in a BCP because in 3 years from now, it might read something somehow weird, right? So I wouldn't put it in a BCP, but just my 2 cents on that.
Okay. Maybe instead of a request just making it more clear that currently there isn't, that currently this is a gap, I guess.
Yeah.
Yeah, okay.
Okay, Ori.
Or Steele, I queued to say the same sort of thing for the BCP. This is a gap that
Can you get closer to the mic?
this is definitely a gap that we feel a lot as web application developers, and I think 100% the working group should reach out and engage the other communities as much as possible. And to the extent that we could have a strong, I agree with the comment about putting it into the BCP, but I still feel that something needs to be said about it somewhere in a stronger manner other than just continuing to reach out.
Okay, thanks. Mike.
I'm not a browser expert, just like I'm not a cryptographer. Is the browser storage landscape part of what's changing in browsers these days, and does it differ between the different major browsers?
As far as I know, there's no like impending dramatic changes in the landscape. And it's also relatively consistent across vendors. So that's my current understanding. I'm seeing some nodding, so good.
Okay, so at least what you're writing probably is generally applicable. Thank you.
Thanks, Mike. Christina.
On the last point, there's Federal Credential Management API work in W3C, and they extended Credman for identity interactions, which means there's a browser in between relying party and the AS. So I assume there's some kind of token storage happening. I might be wrong, but that might be a place to where it could be most effective. And I agree with all the comments that, mentioning it in BCP might be a bit uncomfortable.
That's a good tip. I think that's a great place to start reaching out.
Okay, David. David.
It takes a second to unmute.
Okay.
As far as I know, the browser model is pretty much universally to origin. Some of them are stricter in terms of sandboxing third-party origins under a single top-level origin, so that me seeing a site indirectly through multiple other sites, I can't store the same state. They get sandboxed or don't get storage at all. But the granularity is the origin. So workers aren't isolated from the main page's storage. Actually, web extensions aren't necessarily isolated from the page storage that they're on if the users approve them for whatever permissions they asked for. So it's feedback, but it's a very big ask.
Thanks, David. Tobias.
Yeah, I think Dita started to sort of answer the question that I was going to ask, which is, I think this is a good ask to make of that community. I would just sort of drill in and say, what do we mean by secure storage in terms of tokens? Like, what would the properties of that storage mechanism be? Would it be, obviously, if it's still available to JavaScript applications, then you still have XSS vulnerabilities, but there's, certain isolations that we could make to improve certain vectors of token theft and those sorts of things if those are the attacks we're after sort of securing. So I think drilling into what we would actually be looking for from a secure storage solution from requirements would probably help guide that conversation. Otherwise it would be maybe a bit ambiguous.
Yeah, the specific gap that I'm referencing here is the document talks about using a service worker to acquire the tokens, and if you can do that, then the tokens that are acquired by the service worker are not accessible to the rest of the JavaScript app. However, there is nowhere for the service worker to permanently store those tokens. So if there was like local storage available to the service worker that was isolated to the service worker, that would be a very specific solution to that. Again, caveating with the rest of this is spelled out at length in the draft, but that solves the cross-site scripting attacker being unable to steal the token, but it can still, of course, call the service worker to use the token. So with that in mind, but the other big gap here would be having the ability to, well, using like the Depop with a hardware-backed key, which would require essentially cooperation between operating system making the browser API available, the browsers making an API to be able to use Depop automatically using the hardware-backed key, and then all tying again up to the server. And that would be like the best solution to all of this, because then token theft is not even a problem. That's a much bigger project, I guess. So, and I guess more relevant to Depop, but not something I feel like we can capture as a best practice today, since it doesn't. It's all future work.
So just to follow up on Tobias's comment there, did we capture the properties that we think we need in that case?
There's at least a very specific gap in a relatively small space for what would be a decent solution without going to that sort of next level of hardware-backed keys. So I think we could. I guess I agree with the sentiment of not making it like a request, but I think capturing that as a calling that out as this does not exist currently as of this writing in the document would be helpful.
Okay.
Okay. That's great. I think that's it for the browser BCP. So moving on to OAuth 2.1. There have been, again, a lot of changes since the last discussion. So since draft 7 at the last meeting, we had a good discussion, identified a lot of things to work on, and have been going through that list. I wanted to call out a couple of the main changes here. Again, this shouldn't be surprising since this is mostly based on the discussions we've had. The client ID definition, we had some discussion about that last time. That now is meant to allow for things like clients bringing their own client IDs, since that is something that is currently done. So instead of a trusted third party, it is now possible to create a client ID by an outside party. There's this text around verifying the identity of the resource owner in a couple different places in the draft, which always kind of rubbed me the wrong way about, because it's not really doing any kind of identity verification the way that the rest of the industry thinks about identity verification. It's more about authenticating the user. That's, I think, what we actually meant with the original draft, so that's been fixed. There's a couple of, I think Daniel mentioned this earlier, I've been working with him on making sure that 2.1 has all of the changes that have been discussed in the context of the security BCP. So a lot of those have been now bubbled back into OAuth 2.1. There's a couple of fixes to things, and then, yeah, a couple of new sections based on stuff that was added to the security BCP. There's, what else is interesting here? Yeah, a lot of just sort of mechanical fixes and changes here. I guess that scope one is kind of relevant to another topic that I'm going to talk about in a second. The draft is arranged into these grant types are like main sections in the draft, and the grant types define parameters that are used in the specific grant type, and they all extend from the core token request, which the scope parameter was in that core token request that they all extended from, but it turns out some grant types don't use the scope parameter, depending on what they are, especially once we get into extensions defined elsewhere. So the scope parameter is actually a parameter defined by specific grant types, so that's just been moved. But the stuff that is still left to do, obviously finish making sure that it's in sync with the security BCPs instead of supposed to be a rolling up of that. That's still ongoing. I have a to-do list for that. There's still some normative language that has made its way into the security considerations over the years. So I'm trying to pull all that out into the appropriate section to just make it part of the core spec. And then again, this 97 is, it's just haven't done it yet, which is the making sure that we actually document all of the actual differences from 2.0 and for which roles in the flow somebody will have to actually double check their implementation works with still. So that's sort of my to-do list. Couple of things I wanted to talk about today, and this is getting into Vittorio's write-up of a review from a while back. And this one was interesting. So this term explicit resource owner authentication appears in the client impersonation section. The idea is that if a client is not authenticated, or for whatever reason, client impersonation is possible because anybody can just show up with the client ID and start a flow. There's this text that says the AS should involve the resource owner in that case. And Vittorio commented, is this actually intended to like full on prompt them for credentials every time, or is it supposed to be inserting a prompt to choose between different user accounts? What exactly does this actually mean of like involving the user? I wanted to ask, is this actually intended to only apply to public clients, or is this supposed to also apply to confidential clients for whatever reason? There's questions about what this actually means. So I think it would be great to get some feedback on that. And Vittorio, feel free to clarify your comments if...
I completely forgot this was a long
Okay.
You might be saying this and it didn't happen. I don't remember.
That's an opportunity. All right, I think that means dismiss the issue as OB. Yeah, so this is explicit verification of the authentication event is something that is really tricky to specify in practice, because there's a lot of systems where today there isn't really as strong a notion of an authentication event anymore. It's more of like a risk engine, and the authentication event only happens when you go below a certain threshold and stuff like that. I believe this text, I can't speak directly for it, but I believe this text largely comes from way back in the OAuth1 world, where it was intended as an explicit authentication event, as in log the person out, prompt them for their password again, and then you know that the user's really there. That is, of course, specifying in terms of a solution, not a requirement. The requirement is be really sure that the resource owner is there and that you can interact with them. Stating that in normative language, or is this in security considerations? So it shouldn't be normative language. But stating that in requirements language is difficult. I don't have like a magic phrase that captures that well. But I think that we need to look at it in terms of what we're actually trying to accomplish here, which is to say, we know that the resource owner is there, and maybe even in terms of what we want to avoid, which is basically the quiet login with prompt equals none when we're not totally positive that it really is a client that we know about, and it really is a user that we know about, and it has in fact been allow listed and all of this other stuff. We want to avoid like that case of an attacker sort of quietly creating a session on somebody's behalf without them knowing about it, without them being prompted.
Torsten.
This is Torsten speaking. I think I wrote that text in RFC 6749, and the intention was to edit another security or a check on top of the client authentication for cases where you cannot authenticate the client. That's why it is in the client impersonation section, and you're absolutely right. It was intended for public clients, as I said, and it's in line with as Justin just said, to pop up and get a confirmation from the user. Yeah, I really want that to happen. So I think that is in line with existing methods to do authentication sessions. It's just about the confirmation. It's more user consent. So it's in line with the OAuth 2 philosophy of, well, let's do the user meet the decision using a user consent, which might be outdated today, right? But that was the intention. Have another check for public clients to prevent impersonation. Thank you.
Okay. Thanks, Thorsten.
So
George, go ahead. Go ahead. Do you want to answer? Yeah.
No, go ahead. Go ahead, George.
George.
Oh, can you guys hear me?
Yes.
Okay. I'll just follow on and say what Torsten said. Consent is what I've seen used most for this scenario.
Yeah, that makes sense.
Doesn't really help the user a ton, but it's about what you can do.
I think the Vittorio's comment stems from the specific term resource owner authentication. The question being, do you actually want to re-authenticate the user, or is it an existing authentication session that of whatever assurance as appropriate? Fine. And that sounds like, yes, everybody agrees that. So I think that's the bit to clear up here, is just to make it clear that we don't literally mean ask for their password again. We really just mean make sure that the AS thinks that the user is still confident about their session.
Vittorio, Okta. To me, as long as we have clarity, I'll be satisfied. For what I heard, it looks like the attempt here is to provide extra context to the user, so that if someone is pretending to be Office, but in fact it's a rogue client, the user will have a chance to see it. I'd like to comment that the user is easy to fool. So something that says Office with a Norwegian O instead of a normal O will still work, but I don't think we can do much more than just saying people. So if this is about consent, we should probably, and if this is about giving user context, we should probably say that instead of encroaching into the authentication, which is instead a very explicit primitive that we use elsewhere.
Okay, great. So it sounds like make it clear that this is about putting up something in front of the user, asking for consent. So we will do that. My little buttons disappeared. Can you go to the next slide? Oh, now they're back.
Mm-hmm.
Aha, okay. Similar to the previous discussion on a very similar topic, repeated authorization requests. This is also from the same section, client impersonation. There's text that says the AS should not process repeated authorization requests automatically, again, without involving the user, if the client is not authenticated, or other measures, whatever that means, which I agree is somewhat unclear. But it also seems to, as Vittorio pointed out, prohibit the prompt none flow, which is essentially another authorization request, unless you want to decide that you're okay with the other measures and your use case falls under that. So my thought was maybe the should is fine because it is a should and it's in the security considerations, and that does in fact allow you to decide that whatever you've done for prompt none with no is good enough. Maybe we don't need to clarify. Anybody think that there should be more clarifications needed here?
Thorsten.
This is Thorsten speaking. I mean, I checked the section. It's all in the client impersonation section, RFC 6749. It's mainly intended to approve security for public clients, right? So basically, you could also drop that paragraph because it's covered by the statement that we previously had.
I guess it kind of is. But for public clients still may want to use the prompt none silent refresh flow, which
is kind of a contradiction, because you don't know whom you're talking to. Could be a different client, right? That's why it has a should.
Yeah.
Vittorio.
So for me, the main thing here is that using the iframe for refreshing and getting new tokens is a completely mainstream practice that we know like our products enshrine in our SDKs. And I agree that should, from a lawyering perspective, covers us. Like, so technically we are not preventing this from anyone, but a lot of people look at our specs as guidance over what should or should not be done, pun intended. So here I think that the language there is fine, as long as we add, for example, extra context, as in, okay, if you know what you're doing, do it. Because otherwise here it just suggests that it is, you shouldn't do it. But then at the same time, there is no other way of doing certain operations, because although today we can use rotating refresh tokens, those will not help to move sliding sessions with the IDP. So a lot of people that can still afford this, like people that use CNAMEs to use a relying party and authorization server on the same domain, actually keep using this because it is a better user experience. So again, I'm not against the language, but I think that we should at least clarify and perhaps even call out this particular scenario, as in it's common practice for people to do this for refreshing access tokens without bugging the user.
Thank you, Vittorio. Mike.
Mike Jones, I second what Vittorio just said, that this is common practice and it serves to improve the user experience substantially. So we should be careful not to cut off our nose to spite our face, as they say. To Torsten's comment about, well, how do you know who you're talking to? In some sense, it's going to be the same party you were talking to on the channel the last time. If you were okay authenticating them before, you may choose to be okay authenticating them again.
I think that's where that's the problem, though, is that there isn't an authentication of the client here. So it's possible for an attacker to do a prompt none flow, and if they're able to check off all the list of things they have to do in order to pull off the attack, the silent refresh would result in the attacker getting the tokens. Now that list of things to pull off that attack is kind of long, but it is possible.
Torsten.
This is Torsten, exactly, Mike. That's exactly the problem. You don't know whether the party that requests the refresh is the party you talked to the last time. You don't know. And that's why the text in RFC 6749 recommends you to not silently process such a request. That might be a common practice. I would not consider it the best practice, because it bears the risk that an access token is leaked to an attacker, and we should at least spell that out.
I guess if the attacker can get into the browser and be part of the same channel, yes, but you're already processing stuff on the channel. I mean, we can take it offline, but
okay.
One example would be a DNS poisoning. So you do your flow on your laptop at home. You have a session with the AS. You're fine. You go over to a hotel. You get on their Wi-Fi. Your browser does a silent refresh. Now the DNS resolves to something else because the hotel intercepted the DNS, and now suddenly somebody else's server got the token.
Right, but if you do a DNS attack, then can't you just also use the redirect URL and ask a token anew, regardless of whether it's an iframe or not? Like, I understand that there are risks in here, but those are the usual risks that we are, like in this particular case, the cookie which ties to the user agent is required to pull this thing off. If you manage to get control of this, there are lots of other things that can go wrong. Again, I agree with Torsten. Good to call this particular scenario out so that it's clear and people know where it goes. But just saying should not alone without that extra explanation, to me, I think would unnecessarily scare people.
Torsten, just 1 second. So I'm going to close the mic after Philip. So Torsten, go ahead.
Okay, so I think what's important, there is a combination of different measures that we need to have in place to really get that airtight. And one of them is the redirect URI registration along with the redirect UI checking. I think now in OAuth 2.1, we have a pretty airtight redirect UI checking. So even if someone could try to utilize it, leakage of a code should be prevented to an outside party, right? So if we connect those two pieces in the text, I think it would be fine.
Thanks.
Yeah.
Thanks, Torsten. Philip. And we need to wrap up.
Philip Skokan. Can you hear me all right?
Yep.
Try again. Yeah.
Thank you.
Try again.
So, yeah, I'm starting my note. Philip from Okta. Hi. Adding on top of what Torsten just now agreed to after this exhaustive discussion, some context would be great, other than tying down the redirect URI validation. The thing that is missing there is that when this is done with prompt none public clients in a browser, what we already do today to make sure that we respond to the same party, barring DNS poisoning, which opens up whole other slew of issues, is validating the origin that we post message the response to, and we already do that.
Okay. Thanks, Philip. Okay.
Okay. I think we have a path forward. I think there's just one last slide. Oh, I did want to talk about this.
Take 2 minutes.
2 minutes. This is kind of a blanket issue that covers a bunch of the different points that Vittorio brought up in his comments. So I realized that the native apps BCP, if you read through it, most of what is written there today actually applies to specifically mobile phone OSs and not desktop apps. If you look at what's been deployed and how people use OAuth today, the native apps BCP recommendations are generally followed by mobile app developers and mobile operating systems if they're using OAuth. That is, however, not true for desktop apps. Many desktop apps do not follow the native apps best practice for mainly, for example, popping out to the system browser to do a redirect-based flow. A lot of them will open up their own in-app browser to keep the user experience better. So rather than go point by point through all of the comments from Vittorio, I think the way to resolve this, but also to capture the current state of OAuth, is that scoping the native apps best current practice recommendations specifically to the mobile operating systems, where they are generally followed and do work well and do provide a better experience than other options, and just kind of leaving the desktop world open and unspecified. And because that's kind of the current state of the world, is that we actually don't have a best practice recommendation for desktop apps because people clearly haven't been following it because they're not happy with the user experience in that world if they were to follow the native apps BCP. So that's my proposed resolution for this, is basically take the native apps recommendations and then just make sure that it is specifically referring to mobile operating systems.
Vittorio, and then after that, we're gonna wrap it up.
Great recommendation. I think that we can still do better, as in we can mention the desktop ones and mention explicitly some of the differences. As in, for example, some of the measures that we do on mobile work because of application isolation, which we cannot guarantee on the desktop. But some apps, like for example, the GitHub client, they do use the system browser, and mostly because they cater to a more sophisticated, from the security perspective, audience. So I would feel a bit bad in not mentioning those things at all, because those are important application types. I just simply wouldn't blindly ask people to do the same things that we ask them to do on mobile, because they don't get the same advantages. And as you correctly point out, the experience is not good.
Thank you, Vittorio. And do you want to wrap it up here?
Yep. I think the last thing I wanted to mention was this, it's a lot of text. You can read it later. The TLDR is there's a there's, again, kind of going back to the reorganization of how the grant types are defined in the spec. There's a common section that all grant types extend from, which lists the required parameters for all requests to the token endpoint. That, in doing that process, mistakenly, I had added the client ID parameter into that section because it looks like it's part of all the grant types, but it turns out actually it is not required in OAuth 2, and many grant types that extend OAuth 2 do not include that parameter. So my plan is to keep the client ID in that section, core section, but call it optional since it is included in many of the grant types, but just call it out as optional and say, and have each grant type specifically say whether or not it's required based on that own grant type's requirements. So not really a change in the behavior at all. It's just a change of how the draft is structured. So I think that's my last slide. Yes, this was just how I see the future of this draft. Finished browser BCP, which is imminently coming to, I will be requesting last call on it very soon. After the security BCP leaves this group and goes out into the rest of the IESG, then I would like to, of course, finish syncing those recommendations back into 2.1 and then do a last call for that. That's how I see this going forward.
Awesome. Thank you, Aaron. Okay. Christina and Torsten.
So you click on.
I don't see your slides. Which slide is that?
Hey, I need my wingmans.
Chat, SD chart.
Get out of there.
Database.
That's my huge- Yeah. Thank you. We will consider that for the next meeting.
Torsten, I don't see your slides here.
You don't see my slides?
No.
Okay. But I have uploaded them.
Oh, did you accept the upload in the share screen?
I did.
They seem to be there.
Are they?
Oh, you might need to refresh.
Okay, good morning. My name is Torsten. I'm with Yes, and together with Christina and Tobias, I'm presenting an extension that we have designed that aims to provide a robust means to utilize external mechanisms for client metadata management in the OAuth protocol.
Yeah, it's coming.
Next slide, please. So to give you some context, we are working on a set of protocols called OpenID for verifiable credentials, which aims at providing a holistic solutions for issuance and presentation of verifiable credentials. And all those protocols are based on OAuth and or OpenID Connect. Next slide, please. And the fundamental problem we have run into, and that was discussed at IETF115, is if you take a look under the basic architecture, then you see that there are a multitude of different parties involved. A lot of issuers talk to a lot of wallets and talk to a lot of verifiers, which translated in OAuth means a wallet, if you use the traditional way, would need to register with hundreds, thousands, 10,000s of issuers, and verifiers would need to register with a lot of different wallets going forward. And it just doesn't scale, neither from an operational standpoint, but also from an administrative standpoint. And the conclusion that was, we came to at IETF115, an AS should be able to accept externally managed client IDs. So that has went into OAuth 2.1 now. You call it outside party now, Aaron. That's what I got. All right. So client IDs can be managed outside party. Yeah. So not necessarily trusted.
Okay, so having said that, next slide, please. That was just the beginning. Because now we have agreed on, okay, client IDs and client metadata can be externally managed. The next problem is, or the next challenge is, there is not a single method to do this external management, right? There is not a single method to do it. I just wrote up, or we just wrote up a list of mechanisms that we came across while working on the topic. I mean, dynamic client registration was done in this group, but there are X509 certs out there. There's a mechanism called OpenID Connect Federation. There are DIDs, there's TRAIN, which is a DNS-based mechanism, and there are a lot of other things that people could use. And what we have seen in the past is that certain ecosystems decided, okay, we use this mechanism. So for example, in open banking, a lot of ecosystems use dynamic client registration with software statements. But there are other mechanisms as well. We, for example, at yes.com implemented a proprietary mechanism where a unique client ID is used across 1,000 different ASs. And in the world of wallets, it might be necessary for a wallet, for example, to be connected to different ecosystems. And those different ecosystems will most likely use different trust mechanisms. Just as an example, on the right-hand side, I could imagine that, for example, in the European Union going forward in the IDOS, X509 will play a certain and important role for that. But in other jurisdictions, other mechanisms might need to be used. And the wallet, for example, could be the Microsoft Authenticator, could be the Apple Wallet, could be other wallet. So it's really a general purpose universal tool that cannot be really tied to a certain ecosystem. So the question is, how do those kind of multi-homing wallets accept requests from different verifiers that use different mechanisms? Next slide, please. So we had that in our spec already in previous versions, that the wallet could determine from the request context, request parameter values, the state of the request, and so on, what mechanism would be used. And the mechanism itself has an impact on the way the metadata is sourced, whether the request must be signed, whether the request should be signed, or whether the request must not be signed. And there could also be different request parameters. So for example, in OpenID Connect Federation, there's a parameter called trust chain, thank you, trust chain, that you can use to pass additional data. So this is important to get right. And as you can see, the text that we had previously is a bit ambiguous, and could be complex to implement. So we wanted to have something that is unambiguous and robust to implement. And we had a really lengthy discussion in the working group, a couple of months. And we decided to add a new request parameter. And the new authorization request parameter is used by the client to indicate to the ES what method that particular client intends to use. Next slide, please. We call it the client ID scheme because it basically tells the wallet, the AS in our case, how to interpret the value of the client ID. But it also determines the behavior of the wallet when processing the request. So it determines whether a request needs to be signed and or authenticated. It determines what additional parameters can be or must be present, and where the client metadata can be obtained and how. Because in some cases, you want to only obtain metadata from a trusted resource, from a trusted source. In other cases, it can be self-asserted. The way we designed the mechanism allows the wallet, acting as an AS, to publish the supported schemes in its metadata. We have built that into the OpenID for Verify presentation spec right now, and we plan to extend the support for that for the other specifications of the OpenID for VCs family. Next slide, please. So this is a list of the mechanisms that we have defined so far. The first is pre-registered, which is the traditional classic way of OAuth. So the client ID was previously established with the ES. This is for backward compatibility. Then we've got the redirect. Do you want to say something? After you. Yeah? Okay. After the slide, or? No, on the slide.
Okay, so the second mechanism is the redirect URI, or the client ID equals redirect URI. This is a mechanism that was introduced with SIOP V1. Entity ID is the identifier for the mechanism based on OpenID Connect Federation, and DID signals that the client uses a DID to identify itself. What we are considering right now is to also add mechanisms to use X509 certificates and the train ecosystem for managing the metadata of the clients.
So tall. So to just add a bit of a color, it became one of the extensibility points in the specification. So the way OpenID Verify Implementation spec is written, it needs profiling because it supports different credential formats. And one of such profile exists in ISO, International Standard Organizations. It allows to use MDocs in CBOR on top of OpenID for VP. And that profile, for example, defined client ID scheme X549_ISO because they have a really specific mechanism how they want the verifier to be authenticated by the wallet. So just another example how it's not meant to be an exclusive list. It's meant to have extension points as well.
Thank you. All right, so on the next slide, we have two examples to add more color to what we have described so far. On the left-hand side, you see an authorization request, obviously a request object, that uses the client ID scheme redirect URI. So in that case, by definition, the client ID and the redirect URI must be the same value. And as you can see in the last parameter, you can also add additional client metadata as self-asserted data. And underneath the code example, the request example, you see the processing rules. So this request must not be signed. And as I said, additional parameter can be passed. On the right-hand side, just as a comparison, you see a request that uses OpenID Connect Federation. In this case, the client ID is interpreted as the entity ID. That's a term defined in the OpenID Connect Federation specification, which is then used using well-known location and API endpoints to obtain a trust chain, to validate a trust chain and to get more metadata. In this case, any redirect URI is allowed as long as it is prohibited by the metadata obtained through OpenID Connect Federation. And the same holds true for the metadata. So those are just two examples how we use the mechanism. And what we have seen when writing the PR, it was really amazing to see how simple the specification became after the PR. Because previously we had a rather complicated text that described how the wallet was supposed to process the request. Now we have that extension parameter, and it means we have a very robust modular way to extend the behavior and to plug in the mechanisms that are needed from the different ecosystems. Next slide, please. I think we are through. Do you want to add anything? Or? No, I think, well, I think in generally this is really a question to the group. What we've seen obviously through OAuth is numerous applications, and we listed them earlier on, that have been making use of client IDs that aren't necessarily assigned and managed by the AES, right? They're either from ecosystems, they are large federations, they are obviously, the context we're providing here is in the context of wallets and credential exchange, but in general, the question is, are there more applications out there where this kind of way in which the client is identifying itself to the AES that we don't know about that we should be considering, and is this generally useful in the context of OAuth?
Okay, we have a few minutes here for if people have some thoughts, just ideas or comments, questions. Come on, Vittorio.
I'm waiting for you to corner me. So interesting. I have to admit that I have a hard time following when you are using terminology which is not strictly OAuth. So verifiers and similar. Given that like your wallet sometimes is a client, sometimes is an issuer. So if we are talking in the context of OAuth, I think that it would be very clear if we would use the primitives that we use for OAuth. So, but these might just be my general limitation. But my main point is, in the past, the fact that some customers interpreted the structure of a client ID and took a dependency on it was actually a source of big issues. Let's say that authorization servers use this thing as an identifier. They use their own internal namespacing for their own reasons. And customers, of course, they will occasionally look at stuff that they're not supposed to and write code on the basis of that. And then the moment in which the authorization server changed its own schema, which is fully within its right in classic OAuth, then things broke. Now, I believe I understand how the ability of using structured client IDs makes sense for your scenario. So absolutely makes sense. I'm a bit worried in generalizing it because I feel like what I told the customers in the past, which is I'll help you through this hurdle, but you got it yourself. This wasn't part of the contract. Instead, this will somewhat validate that kind of behavior. And so all the people that today are using client IDs as they were originally intended, as just identifiers from the authorization server, will now have to cope with these retroactively. So that would be, at the very least, I would recommend putting a language in the spec that says, please don't do that. And remember that there are still a number of scenarios in which those are assigned identifiers and not really structured. And as a client, you are not supposed to really understand it or act upon it.
Thank you. So first of all, there was a reason why I put AS in brackets. So the wallet in this use cases acts as an authorization solver. Regarding structuring, the client ID not necessarily be structured. The proposal or that what we have designed in OpenID for VP gives a label, right, or passes a label to the AS how to interpret the client ID. Whether the client ID itself is structured, it's up to the method being used. If you're a pre-registered client ID, it's up to the AS how that thing is being interpreted. And coming back to the basic, the fundamental question, I think we already crossed the point where we assume that the AS manages client IDs. There was the topic of the discussion at IETF116. So OAuth 2.1 already allows outside parties to manage the client IDs. And this is done in a couple of places. We just set on top of that and offer a parameter that can be used to really, in an unambiguous way, to indicate what's the mechanism that is used by the outside party to manage the client ID and metadata. That's all we do.
Okay, we need to wrap it up quickly. Peter.
Okay. Yeah, this is actually quite interesting, especially in the context of some of the workload identity topics that we'll discuss a little bit later as well. When we're looking at workload identities, they can come and go and spin up and scale up and down. And so this idea of being certainly not being not managing for the AAs cannot manage those client IDs. And so having mechanisms to help make that easier and communicate that certainly would be of interest there as well. And Evan, I know if you're in the audience, this might be a nice sort of hallway conversation to have as well.
Thanks, Peter. Aaron, any comments, quick comments that you have here?
Hi, Aaron Parecki. I agree with most of what you've laid out here. I think it makes sense. However, my question is why, in which situations do you see a parameter actually being required for this to indicate the scheme? Because in my experience as someone who has written specs and implemented a system that involves non-AS managed client IDs, it works in an ecosystem where everybody has with outside information agreed upon this system, and it's not really a problem, and we don't need the indication of which scheme was used. So is there a specific reason in the scenario where that parameter is required? And if there is, can you make sure it's very clear when you would need to use that parameter and that you aren't expecting everybody to start using this parameter even if they don't need it, I guess.
Okay, a quick answer, and then we'll finish here.
Yeah, I think the simplest answer to that, because you're quite right, there are plenty of ASs out there that already do this, and effectively they kind of treat them like they are pre-registered client IDs in the sense of OAuth when they're not really. And the problem with having like that informally, as the only pattern is, you end up having to kind of sniff the client ID arbitrarily and try and figure out if there is any structure to it, which can be quite brittle in certain situations and hard to extend.
Sorry, I think it's the multi-homing nature of the wallet that Torsten had on the slide, whereas the same AS has to support multiple ecosystem, and that is emerging increasingly as a pattern. So I know Torsten used Microsoft Syndicator as an example. So in certain places, we were forced to do DIDs. In other places, we were forced to do X549. And as a wallet accepting it, it has been, the tags that was there before was actually really, really ugly. It's like sniff the client ID if it's HTTPS, and if it has this parameter, do this. So just to, yeah.
Thanks, Christina. Nat.
Okay, so I'm not Sakimura. I'll be pretty quick, I think. It's not
awesome.
Very complicated topic. So what it is, I'm going to talk about the POP architecture document. It describes proof of possession architecture. All right, you've got the abstract down here. Can you go to the next slide? This work started back in 2014. It's a pretty well-written draft, I think, and it continued developing until like 2017 or something like that. Justin Richard here is one of the author, by the way. Yeah, it's a long time ago, right? And because it's been a long time ago, I somehow was assuming that the work was finished, but please go to the next one. So, that's 9 years ago, and I was assuming the work was completed. And I was reviewing one academic paper this January, and the author of the paper was referring to some of the concepts which was explained in this draft with their own language. So I pointed them out that maybe you guys want to have a look at this one and you align the terminology with this one. And I pointed them to the OAuth working group page. They came back. I can't find them. All right. And I said, really? And went to the OAuth page, and no, it's not there because. Next slide, please. Because that draft was marked dead.
Oh, really?
Yes.
Okay.
And you can see the reviewers review results. It's almost ready, and it went dead. Okay. So next, please. So I still believe that this draft has useful information. At least it will give us the common language to speak. Some context, right? And we are talking about sender constraint a lot these days.
Yeah.
So it should really help. So next page, please. My question is, do we have an appetite to have it cross the goal line so that it can be referenced? The current state, it is not. And if so, what's the next step? So that's probably a question to chair and
well, I don't have the history of that, so it was probably way before my time, but I want to hear from the group here, like, what do people think that have that history and knowledge? And maybe one of the, like, Justin is here, and I think also Hannes, co-author, is on this. So what do you think?
I can start and say a few words.
Yeah, go ahead.
Yeah, obviously back then we worked on a bunch of documents, and this was kind of the big picture overview document defining the threats and the terminology and so on. But it looked like the authors back then had lost interest and steam on it. So like if Nat has the energy to pick this up and to progress and update, because it requires updating because a couple of things have changed. So like it's really up to like you, Nat, to pick up the ball, or maybe with Justin to run with it.
Okay, Justin.
Justin Richer. I had actually forgotten that I was a co-author on this document until the other day when Nat was chatting with me about this. That's how long ago this was. And at the time, we had grandiose plans to move OAuth2 beyond proof of possession and define sort of multiple different non-bearer mechanisms. That sort of grand unified scheme never really came to fruition. Because like we had MAC tokens, we had the really terrible HTTP-based signing thing that I came up with ages ago. It was like jots in weird places with hashes everywhere and not in any of the clever ways that other people have been doing it lately. In the intervening time, we've come up with Depop, we've come up with MTLS OAuth. I've proposed to this working group, one using HTTP message signatures. All of these should fit under this same umbrella. I'm with Nat that like it makes sense to sort of have this terminology. So like with the document as close as it was to finish, if it is procedurally straightforward for us to clean up a couple of references, maybe add text that points to the MTLS and Depop drafts, then maybe we can push that forward. I don't know if, because this is so expired, even at the point where it had IESG review, I don't know what we need to do. Roman's behind me is probably going to tell me how hard this actually is.
Okay, Roman, go ahead.
Hi, it's Roman. So I heard procedural, so I felt the need to come up here. Yeah, so as far as I can tell, I don't remember the history at all. We went as far as IETF last call, and then nothing happened after that. So exactly how you said, just if we want to restart this, actually all of the history doesn't matter. I mean, it's been 7 years, so this should be the very beginning. You know, we have a document, we're going to need to work with last call, IETF last call, and kind of bring it forward. So it's like being new.
Yeah, makes sense. Richard. Richard. Having trouble? Technical. There you go.
Just had to get through the permissions prompts.
Yeah.
The usual meet echo 10-second delay. No, so I am new to this. I'm far newer to this discussion than this draft. But my impression coming into this space with some fresh eyes nowadays is that proof of possession is kind of the way of the future for this community. The way things are going. There's all the mechanisms Justin mentioned. I think there's all the verifiable credential stuff that was discussed a little earlier, as well as the browser considerations that that folks were discussing earlier. So I think, you know, we're headed toward a world where proof of possession in various flavors is going to be way more important. And so I think it makes sense to revive this draft, assuming that there's energy by the authors to move it forward.
Thanks, Richard. Joseph.
Yeah, Joe Soloway. I think this would be useful. I mean, I had my own little adventure kind of looking into Depop and things like that earlier this year. And like this, I actually like this document was helpful. I think it needs to be updated a bit, but I'd be happy to review.
Awesome.
So I think it's a good thing to do.
Thanks, Joe. Christina.
It's pretty hard to say without knowing from where this draft is intended to be referenced, whether that reference, you know, what does it mean? And I think, at least from my perspective, I need time to be able to re-review the draft before I'm able to say, like, it should, you know, be revived or not. Because even if it was almost ready, I'm sure there was a reason why it was not finished, as always. So can we get a bit more time for the working group, if that's okay?
So I guess, Christina, you're asking like for more time to. Okay.
What was that?
Well,
more time for what? I didn't. The microphone didn't pick it up. What was the answer?
This is Thorsten speaking. Let's first focus on the context question. So Nat, could you shed some light more on the context where you want to utilize the draft? So what is the context where you want to reference that? Where
Where should it be used?
Yeah, so it's not only within the IETF, but a lot of people seems to be talking about this, sender constraint or key constraint kind of things, and with different vocabulary. So, having something to point them to come together with a terminology to be used would be generally profitable for the community to foster the understanding.
Okay. Torsten, and then we have to wrap it up here.
Okay, Torsten again. So I understand that. I'm a bit struggling to understand how the POP architecture that was abandoned long time ago fits into that picture, given that we now have DPOP and MTLS that both do sender constraint access tokens.
Mm-hmm.
So if we just want to have the terminology get straight, perhaps that should go into OAuth 2.1. Or the security BCP. I mean, the security BCP calls out for use of sender constraint access tokens, and it also has some definition of it, I guess. Looking onto Daniel. Right. Just as an alternative, if you just want to get the terminology straight, I mean, there are existing drafts that are used in production. I don't think we want to change those.
So Nat, is it just terminology or is it more than that?
It's more than that. So
Okay.
it just lists out the terminology, then it lists out the potential threats that could be addressed with each type of things. And
Right.
The drafts that we currently have in OAuth, it's not exhausting all those components, which
Right.
is explained in this draft.
Okay. Roman, go ahead.
Sorry, I keep getting knocked off the internet, so I can't get in the queue. I was just going to say, I don't know what the right answer is, but we really need to finish the security BCP. So if we need to rev it later, let's rev it, but let's get it out the door. So let's not hold that up.
Okay. Let's have more discussion. Maybe
Okay,
you and I
sure.
can discuss
Yeah.
it and we can see what's the next step.
So I'm done?
Yes.
Okay, thank you.
Thank you, Nat. I appreciate it. Okay. Evan.
Hey, folks.
Let me hand it to you. Are you logged in here?
Yeah, I don't know if I'll get the thing or not. It's not a
Oh,
big
here.
deal either way.
Yeah.
Oh, that looks about right. Okay. Hello, everybody. Let's see if this works. There we go. My name's Evan. I'm actually presenting today with Peter, who is remote. I don't know if he is able to speak or not.
I'm here, Evan.
Hey, Peter. Okay. Yeah, so as my badge says, helpfully labeled, I'm new here. So please excuse any imposter-like things that you might see. I've been talking to Peter for a few months now about the intersection of workload identity, SPIFFE in particular, and OAuth. We started our conversations and, how do these things interop with each other? We'll talk a little bit about that today. And as we kind of continued conversation, also realized that there was a whole bunch of work going on in SPIFFE community, workload identity community, that also very similar work going on here in OAuth community. So the goal of this session today, my presentation today, is to kind of give a little bit of context on SPIFFE and workload identity in general, and explore kind of a set of use cases that we have. There's 7 of them I've got here today, and kind of see how they map it into OAuth, and also start some conversations about how we can, number one, make it clear how these two things work together, and number two, also if we can kind of like converge some of this parallel work that we have going on, would be awesome. So I'm here today, also tomorrow, to have those conversations. So if any of this is interesting, please tap me on the shoulder. I'll be around. Right, so first, what is all this stuff? A SPIFFE is a set of specifications for workload identity, and Spire's software implementation of that. There are several implementations of SPIFFE. Spire is the only kind of like full-blown standalone implementation. A lot of other implementations baked into other products and projects like Service Mesh, things like this. What does SPIFFE do? SPIFFE does really well to solve this problem of secure introduction or secret zero, bootstrap, however you want to call that. So SPIFFE solves this bottom turtle problem. workloads don't need to have any kind of prior knowledge of who they are. They don't need to have any credential in order to join this scheme. It works very, very well in highly elastic distributed compute environments. As Peter mentioned earlier, workloads come and go all the time. They need to be able to come up, get an identity, talk to things, spin down in a matter of seconds. So Spiffy is a very good fit for this. Also, because we don't require any kind of secret injection, and we solve this secret zero through a series of measurements, which I'll talk a little bit about. The delivery of these credentials is fully automated, and this enables us to have very, very short-lived documents and key rotation from the root all the way down. So these are some of the big differences between Spiffy and other schemes out there. So the things it does not do is we call authorization out of scope. So we don't reason about authorization at all. We provide only this identity framework, a way to authenticate workloads and reason about their identities. And we look towards authorization by building a solid foundation upon which people bring their own authorization. This can be, anything from simple allow list to all the way up to, OPA rego and dynamic policy computation, things like that. We also don't really reason about human identities. We stay in our lane. Workload identities. There are some places where these things overlap, and which is part of the reason why we're here. And there are some people who are using Spiffy for workload identity, but are using Spiffy for human identities rather, but it's super limited kind of access to production type stuff. Finally, we don't like to define any new documents. We use all existing documents. We kind of define these profiles on top. Primary idea here is we want to work with the software you have already. And so why should you care about any of this? The two documents we support today, X509 and JOT. Spiffy, we call these SVIDs. But they're different. I mentioned there's the key infrastructure is like highly rotational. And we provide not only the credentials for the identity, but we also provide the bundles, the trust bundles. So, what root keys that workload should be trusting when it talks to other parties. And so Spiffy and OAuth have a lot of overlap. They're very different, but also very similar. I like to think of them as kind of two sides of the same coin. There's a lot of shared problems I mentioned, and interoper as well. These are the primary reasons that I'm here today. So real quick, before I jump into those use cases, I thought I'll just kind of speed through a quick worked example of a Spire deployment so that we have some shared context. Spire is comprised of a server and agent component, and the agent works together with the server to do remote attestation flows. This is what we call node attestation. It's pluggable. It can be backed by hardware TPM, can also be backed by cloud provider APIs, things along these lines. The agent also provides what's called what we call workload attestation. So when a workload boots up, it attaches to this agent. The agent measures it out of band, figures out who it is, and then works together with the server to issue a credential to those workloads. And that's, X509 cert, keys, JOTs, and the bundles, of course. And once you have all these things together, the workloads can communicate with each other, authenticate each other without the involvement of any of the Spiffy Spire infrastructure. Right, so there we go. 7 use cases. I know I'm going quick because I don't have a lot of time here. The first, I'll try to kind of build up. These will build up upon each other. So the first is super basic, kind of just, how do we do the interop across these different domains? If we have a bunch of workloads operating a Spiffy domain, they want to access a resource that's protected by OAuth. What does this look like? We have people doing this today. It's very much choose your own adventure. It's kind of undefined. So, thinking about what this should look like is of a lot of interest, and maybe writing something about that is also of a lot of interest in our community. Related to that, is this idea of registration in OAuth. I believe this is kind of, thank you, Peter, earlier for connecting the dots with the client trust presentation. We have, all these hosts workloads that have an identity already. They want to enter into this OAuth ecosystem. How can we do this in a way that, is not super heavyweight? So, if we can transpose Spiffy identities, for example, into OAuth ecosystem, that would be awesome. The thing to highlight here is that, the Spiffy keys rotate pretty frequently. So in order for somebody to validate these Spiffy identities, they need to also be able to call out and be able to kind of track those key rotations. Third is preserve these call stack identities. So we have problems in Spiffy where there's large microservice graph, and as requests transit this microservice graph, oftentimes you want to know the path that this request is taken through that through that infrastructure. There's all kinds of policy that people want to put here, and this also kind of blends in with user identity. People want to know, hey, this user has issued this request and I can prove that. Also, here is the path through my infrastructure that request took. And then at the end, you write policy that enforces all of this stuff. So one example of that could be like a payment service. This is actually a real use case we have. Payment service. The payment service only wants to move money if it can prove that the owner of that account issued this request and that request is transited the fraud detection service on its way to the payment service. Fraud detection service might not be the N-1 hop. And so how do we kind of preserve these identities and wrap them up or chain them or whatnot as they traverse the stack? Also, how can we have, these spiffy workload identities coexist with the user identities, and what does that coexistence look like? Next, we have token theft. So, this is like, hey, we've propagated this token all the way down the chain. Spiffy requires audience value to be set, but it's still kind of like not the strongest mechanism in the world. And so we're looking for ways to kind of like bind those tokens to the request itself such that it can't be popped off and replayed against other workloads in the stack. I should add to that one that, it's really important for Spiffy to kind of avoid like expensive network calls on each one of these hops. This is like a pattern that turns a lot of noses up in our community because of the availability and performance implications of doing that. So we try to look for solutions that can be kind of done locally, quickly. Fifth is it's fine-grained authorization. I don't know how well that fits in here, but as all these attestation processes I was talking about before, as those occur, they throw off all this really useful information. And right now, we don't actually keep any of this information. We log it, but we don't have a way to utilize it. And recording it somehow, emitting it, distributing it, and consuming it at a policy decision point is something that we're trying to figure out how to do. All this kind of stuff is super useful, for example, if you're trying to implement, attribute-based access control system. So, I'd give a little sample policy here of how you might kind of consume these things. So that's number 5. I've got a 6th one here, which is kind of just inter-domain data distribution. Spiffy has federation as a federated scheme. We took a lot of influence from OIDC on how to support that. So, there's a JWKS document, that kind of stuff. Biggest difference here is we support X509 too. So you can federate X509 routes and do TLS on TLS between these domains. But how do you find that JWKS endpoint? We don't have like a great solution for that right now. Pushes off onto an operator. So an operator will say, here's my trust domain, here's the endpoint, here's the scheme you should be using when you talk to that endpoint, which is effectively, how you validate, authenticate that endpoint. And this information right now is exchanged kind of operator to operator. Once that's exchanged and the federation relationship comes up, everything kind of hums along by itself. But the distribution of this information in a trustworthy way is still pretty difficult. We also don't have any way to kind of like package that metadata up and ship it off.
So Evan, we are almost running out of time.
Slide.
So yeah, so maybe choose something that just to allow that the community to provide you some feedback here.
Sure. So I did have one more use case here, but it's kind of a little further off. So I'll just skip over it. This is kind of about, similar to the last one, how do we collect all this information and use it in higher level systems for risk measurement, remediation, things like this. Spire is in a pretty good position to remediate, as are other adjunct systems. Also, when every workload has an identity and everything's authenticated, the level of visibility is phenomenal. And so we want to kind of collect all this information and use it to respond to risks in the system. So I'll just fast forward here. There's a lot of other things that can be done. If there's anything here that comes to mind for you, please do. Let's talk in the next day or two. And then I'll pass it to Peter to kind of help me map all of this stuff onto the work that's been going on in this group.
Yeah, so I think in terms of next steps, one of the things that we're thinking about is just starting off by documenting some of the use cases, but then also, I think there's sort of a number of OAuth artifacts or standards that we can already start referencing and just giving guidance. I think one of the things is just making it clear and helping people understand how they can use OAuth to connect these two ecosystems. And so this is sort of this idea of, maybe we need to create a best current practice to enable developers that need to connect SPIFFE and OAuth ecosystems and give them clear guidance so that you don't have to go on your own adventure or even misadventure in the process. And really opening to this group for feedback and are folks interested in this? Do they have similar problems? And yeah, just would this be a useful artifact for people?
Okay, thanks, Peter and Evan.
Thank you, everyone.
No, hold on, stay here. Vittorio.
Oh, I didn't see that. Sorry.
Hi, Vittorio. Again, thank you for the presentation. The scenarios that you have shown are very real, very interesting scenarios. The thing that what kept coming to mind as I was hearing you speak is that I'm wondering whether there is a bit of a layering mismatch. Let's say that auth doesn't do identity. It can help transport and can do all the things that you describe, but it seems like this is a particular application of the tools and the primitives that auth offers. So somehow I would expect the SPIFFE side to say this is how we use auth, rather than auth saying here there is a particular use of the primitives that we defined. So just to summarize, I think those are very valid scenarios, and I think the industry would benefit from having more details. I'm not sure if that's the charter of the auth, but it's just my impression.
Thanks, Vittorio. Do you have any comment?
Yeah, I don't know what side of the house is best for these things to land on. I can see the need for them, right? Certainly, I put my hand up when the OAuth MTLS work was going on to try my best to make, a hole through which SPIFFE could fit there. But there's still more work to be done because the keys rotate. There's kind of unknown how we can kind of keep the OAuth server up to date with these keys. There's no answer there. And so, we can certainly define some stuff on SPIFFE side as to how these interactions are supposed to look, but there's also, I feel like, there's a few gaps on the OAuth side as well. And I'm far from OAuth expert, I'm passingly familiar, so I would love to kind of explore those things in more detail, perhaps in the hallway.
Joe.
Yeah, Joe Soloway, I think that I agree that I think this is it would be useful to kind of define some of this. I don't know exactly where. I think it would be useful for this document to be referenced from the IETF or from the working group, whether it happens here or somewhere else. I don't know. I mean, I think you also, when you listed all of your use cases there was a lot, and all of them were very, there's a lot of compelling ones in there for me. I don't know if they all fit within, this group, but I think it would be good to kind of figure out how these things really fit together, because I can see some really good use cases being solved by these.
Thank you, absolutely. And I want to be clear, I'm not trying to push work on anyone. We're happy to take this work in our community. The most important thing is to have collaboration and input from you all and work together towards those things.
Awesome. Thank you, Evan. That was
Thank
great.
you.
Thank you all, and see you Friday.
Thank you all.
I purposefully didn't bring up the third-party client versus